Hi, we're here today to study exponentials. As you recall, exponential equations are those that have within the exponent an x, or whatever my independent variable is, p or t or whatever you're solving for. So within there's some larger print value, like a number, and then up here in this position, that's where you're seeing your independent variable, your x. So there's something up here with an x, there's something here that's a number, okay? And I mention that because sometimes people get confused about what the category even is. If you have like an x to the second or an x to the third, that would be a quadratic or a polynomial. This would be quadratic. Both of these would be polynomials. But if you have a number with an x that's up in the exponent, that's an exponential. So the idea behind solving an exponential is that you want to try to use related bases if you possibly can. Once you have bases that are the same, then the exponents on each side of the equation have to be equal to each other. Because if you have something like 7 to whatever equals 7 to whatever, and those are filled in with different things, the equals means equivalent. And the bases already match, so the exponents have to match, okay? If it's impossible to use related bases, you're going to use logarithms. Logarithms, remember, are this definition. So when I have b to the c equals a, that's the same as this. Logs are stored in your calculator, so all you need to do is be able to switch between exponential and log form, and you'll be able to evaluate even the strange cases where the bases are not related, okay? So if you did not remember this definition, make sure that that is written down, you put a star by it, and better yet, even just, learn it, know it forever, even without having to look it up. Okay, so you have 4 problems to do. This first problem, actually with all the problems, I'm going to start out with asking myself, once I see that it's exponential, the question I'm going to ask myself is, are the bases related? Here, the bases are actually identical. So because there's this equal sign, and because these bases are already the same, that implies that those exponents have to be the same. Otherwise, that equal sign wouldn't be there. This is now a linear equation. We subtract x from both sides. We subtract 6 from both sides, subtract 3 from both sides. And we would get that x is negative 10. Then at the end, you could double check by putting back into the equation that value of x. I'd have 6, and then negative 10 minus 7 would be my exponent. On the other side, I'd have 6. 2 times negative 10 plus 3. Okay, and I would do, like order of operations wise, I would think about each of those exponents as their own little mini problem. So on this side, I'd have 6 to the negative 17. Over here, I'd have 6 to the, negative 20 plus 3 is also negative 17. Those match. The next question. Oh, this is a great time to remind yourselves about e. E is a number. It is similar to pi in that it also is an irrational number, which means in decimal version, it goes on forever without repeating. The decimal estimate of e is 2.718. E is the base of the natural log. So you could write any log with a little subscript, but log base e is used so commonly that it has its own symbol. It's an L with an N, which means natural log. It came from a different language than English where the word order is different. Okay, so if you take a look back here, this indeed is exponential because e is a number, x is my independent variable. I have a variable in the exponent, a number as a base. And the bases are the same, so much like with the last question, we would set our exponents equal to each other. We would subtract the 3x over to one side, and then, or subtract the 3x from both sides, I should have said, and then divide both sides by 2. okay? And then to check my solution of 2, I would substitute back in that side. If I put a 2 in there, 5 times 2 is 10. On the other side, I'd have 3 times 2, which is 6, plus 4. Are those the same thing? Yes, they are. Okay, the other 2 problems require a little more effort. So looking at number 3, I've got the base of 8, and on the other side, I just have 35. I could think of it as 35 to the 1 if you want. Are those bases? Bases I can relate? 8, 35. That's the thing that's hard to think about. So I would start by thinking about, okay, I could do 8. 8 times 8 is 64. I'm already past 35. 8 is also 2 to the 3rd. Can I write 35 as 2 to something? I don't think so. If I keep multiplying by 2, I'm going to get even numbers, and 35 is odd. Okay, so I don't think these are related bases. So in this case, we need to use our definition of a logarithm, okay? So a log is an exponent, is a key sentence from where I stand. Okay, and I think of this as being my equal sign. So the log is going to equal my exponent. What would we call the base of this statement? If you just thought 8, that's right. Log base 8. When we talk about things like this is called a base, this is called an exponent. Right? If I talk about 3 to the 4th, the 3 is the base, the 4 is the exponent. So in my statement, 8 to the x, the base is 8. And my log is going to have a thing here. It's going to have an equal sign and then something here. And a log is the exponent. So the exponent is what has to go on the other side of the equation. And then it's the 35 that goes in that slot. Okay, and some people look at this and they say, okay, I can see that 8 to the x equals 35 right there, like that little loop. Okay, so on my calculator, I need to be able to figure out what the base 8 log of 35 is. This highly depends on what kind of calculator you're using. This is part of the reason it's to your advantage to own your own calculator, because then you can know how it works. You don't need to know how all the calculators work. Okay, so the base 8 log of 35 on this calculator can be found by within the math menu, scrolling down or actually scrolling up from the bottom until you get to this log base command. Okay, and we wanted the base 8 log of 35. Now you notice that with this calculator, it's really nice because it can look just like it does on the paper, and I can get my answer. I like to round to 3 decimal places. I think that's a good amount. So 1.709, the 9 would go up to being 10 because of the 7. So 1.710 is what I would write down. And I would use wiggly equal sign to show that I've rounded that. Okay, now if you don't have that feature on your calculator using one of the older calculators, there is a formula that we used to use back in the day before that button existed. And anytime you have a log with a different base, so say this B is your base, and you're trying to find this, call it C. You can use a base that actually is on your calculator, like base 10, and then this value goes on the top, this value goes on the bottom. Okay, the only people who do not have to know this formula are people who keep track of their calculator and know that their calculator has that feature. If you borrow a calculator, you don't know what's going to be on there. You might need to know this, okay? So in this problem, since we want to do the base 8 log of 35, you would have the 35 be on the top and the 8 be on the bottom. The 8 is the base is on the bottom. And you can use whatever base then you want. Okay, whatever base your calculator features. So I'll show you that turns out the same. Okay, so here on my calculator, in red right now, is my base 10 log button. I could do the base 10 log of 35, and then divide that by the base 8, base 10 log of 8. Okay, and you see that I got the same final answer, the 1.7, we're rounding it to 10. Okay, so it does work, it is possible. The only people who have permission not to know that are people who are going to be careful to have their own calculator with them, and it has that button. All right, fourth example. Ooh, bases of 16 and 1/4. Now, it might not look to you at first like these are related bases, but they are. 4 squared is 16. And if I take 4 to the -1, negative exponents move things upstairs and downstairs in a fraction. This is not a fraction, so it's already upstairs. So 4 to the -1 is actually this. Okay, if you ever wanted to check that, you could. Again, calculator. So 4 to the -1st power. Oh yeah, that's a 4th, right? Yeah, that's a 4th. Okay, so I know these two facts, okay? So we're going to replace each of the given bases using the information I just wrote to the right. That will allow me to have related bases and use what we did in the first two problems. So 16 is 4 squared. And then this part of the problem, I'm just recopying. 1/4 is 4 to the -1. I'm replacing that, and then this part is just being recopied, brought down. Okay, now when you have a power to a power, so you had like x squared to the 3rd, that means you have 3 copies of x squared multiplied together. So I have 1, 2, 3, 4, 5, 6 x's, x to the 6th. Okay, this is to remind you that when you have a power to a power, you multiply. So that's what we're going to do here. I see 2 cases of power to a power, here and here. Now, because you're multiplying a single number times something that has 2 terms, you have to distribute. Okay, if I had just written this out, I hope you all would know that you distribute that 2. The 2 is being multiplied by the entire expression. So here we'd have 4, we're going to distribute, because that's how you multiply. 6x minus 4. Over here, big 4, this -1 gets distributed, so that's -5 plus x. Okay, now I have an equal sign equation with equal bases, and in order to have this equal be a true thing, be a true statement, actually equal, that means that the exponents have to be equal. Okay, this is a nice little linear equation, like little algebra 1 problem. We can do this. We're going to subtract x from both sides. I'm going to add 4 to both sides. Divide by 5 on both sides. You can write it in a decimal format or a fraction. It does not matter. Okay? I hope this is helpful. It is really important that you do problems. That is the only way to learn algebra. Watching someone else do problems is not going to teach you anything. I've watched hours upon hours of NFL football. I am still unable to catch a football. Just thought I'd tell you. Okay, watching isn't going to teach you. So please show your teacher your video notes and then go ahead and work on the problem set. Remember that the problem sets all go into your portfolio. Thank you.